Hi everyone, welcome to my YouTube channel. I am Madam Rosmaya. In this video, we are going to discuss on progressive wave equation. Okay, we are going to derive this equation. Okay, there are three equations. Actually, they are all the same. Only the terms used is different because some of the terms are related with each other. Okay, so next slide. So let's say this is the this is the graph of wave where the wave profile move to the right. Okay, and the amplitude of the wave is A, and this is y against x distance. Okay, let's say at time 0 or at initial, the time 0, so the y is 0. Okay, so the y is displacement. Okay, the y is 0. So the graph is the sinusoidal shape. So therefore, we can write the equation as y equals to a sine omega t. Okay, this is at time 0. Okay, when it comes to the certain time t, so what happened to y? Okay, so the y will be different, and we are going to add the phase difference between the two waves. Now the new wave occur here. Okay, so this is the phase difference. Okay, let's say we use the symbol phi for phase difference. So the now the new equations become y equals to a sine bracket omega t minus phi. So what how are we going to find this phi? So this phi is equals to 2 pi x per lambda. So we use ratio method to find the phi, the phase difference between the two waves that has already moved to a distance here, x, a distance here. Then the wave equations, the y becomes y equals to a sine bracket omega t minus phi. Okay, so you substitute the phi formula is 2 pi x per lambda into the equation. So this is equation 1. Okay, recall to what we have learned before, how to find the phase difference. So if one complete wave, the phase difference is 2 pi radian. Okay, for 1 lambda. The wavelength is lambda, but the phase difference is 2 pi radian. So if between 2 points here, so the phase difference, we can use ratio method. So let's say the distance here x, this is x-axis x. Okay, so the phi will be, okay, 2 pi is lambda, so this phi in radian will be x. So we can use ratio method. So 2 pi per phi equals to lambda per x, and we cross multiply, we get phi equals to 2 pi x per lambda. So this is how where the phi phase difference formula comes from. Okay, so now next we go to next slide. Okay, this is the first progressive wave equation. We can also relate the angular velocity to 2 pi f. Okay, angular frequency or angular velocity equals to 2 pi f. So f is 1 per t. So you substitute into here angular frequency 2 pi per t. So we can factor out 2 pi. So bracket become t per period. This t is period minus x per lambda wavelength. So this is second equation. So the third equation, we can substitute the 1 per lambda here, x per lambda here. So v equals to f lambda, and f is lambda per t. So you can bring lambda to the right side, becomes v per lambda equals to 1 per t. So this equation 1 per t here, you can substitute into here as v per lambda. Okay. So lambda here, wavelength, we can factor out. So together with 2 pi, okay, 2 pi per lambda becomes bracket vt minus x. So this is the third equations. So these three equations is the progressive wave equations. So depends on the question that asked you in the future. So whether they want to give in which form, okay, the progressive wave equation. Okay, and the 2 pi per lambda is called wave number. Okay, so we usually we use symbol k for the wave number. So the first equation can become y equals to a sine bracket omega t minus kx, and the third equation can become y equals to a sine k, okay, bracket vt minus x. Okay, so now if the wave move to the left, okay, like this one, so you just change the minus just now become positive, okay, plus. So if the wave profile move to the left, so all the three equations just now you replace the minus to plus. Okay, so let's try one question. Okay, a wave has wavelength 5 cm, velocity 40 cm per second, and amplitude 2 cm in the positive x direction. So this is positive x direction. Okay, write the equation for the wave such that when t equals to 0, the displacement at x equals to 0 is maximum in the negative direction. Okay, so amplitude is given 2 cm and wavelength 5 cm. Velocity 40 cm per second. So because of the graph mentioned here is when t0 displacement x is 0 is maximum at the negative direction. So how you can imagine this? So this is how to imagine. Okay, at x0 here, at x0, and the t0, okay, so at time 0 here, so that's mean at this position, it's the negative direction here, negative direction, and maximum. So it will be, if the wave is like this shape, so this is the throw of the wave. Okay, so it form a cosine graph. So a cosine graph, the equation at t0 will be y equals to negative a cos omega t. So the amplitude here is a here, and it's a cosine graph. It's a cosine graph, so it's negative a, negative a. Okay, so now we are going to find omega here, angular frequency, and we also substitute amplitude 2. Okay, it's negative 2 cos omega t. Okay, so the angular frequency we can use 2 pi f, but before that we find f first. So f is v per lambda, so 40 per 5, wavelength 8. So angular frequency will be 2 pi f, so 2 pi times 8, and we get 16 pi. So now we can substitute this 16 pi into here. So this is the equation for the progressive wave which move in the positive x direction. So in the positive x direction, this is at initial time equals to 0. So if it move, the wave profile move to the right, okay, which is in the positive x direction, so we must add the phase minus 2 pi x per lambda. Okay, next we are going to find lambda, the wavelength. Wavelength already found 5. Okay, so this is the wave profile. This is the progressive wave equation when the wave profile move in the positive x direction. Okay, so we substitute the wavelength there. We can also simplify this equation. 16 pi, so 2 pi, we can factor out 2 pi, so bracket become 8t minus x per 5. Okay, so this is the simplest equation if the wave profile move to the right or in the positive x direction. So given by y equals to negative 2 cos 2 pi bracket 8t minus x per 5. Okay, so that's all for our discussion today. Hopefully you all can understand, and thank you for watching, and don't forget to subscribe my channel for more video to come in the future. Okay, bye bye.